Hi everyone. This is a video on JC1 H1 mathematics, and we are on the chapter of permutation and combinations. Alright, and in this video, we'll go through some of the tutorial questions that we didn't get through in class. So far, we have already covered some. Alright, and I think this video will help you to boost the remainder ones so that you can have a idea on how do you solve these questions. Okay, so without further ado, let us right now turn to turn to question 8. Okay, question 8. So so once again, to recap, we have a few things going on here. We have our n factorial, we have our npr, where it will be how many ways to arrange r objects out of a total of n objects, and how many ways to choose, so ncr. Okay, mainly these three things. Okay, so in how many ways can a committee of 3 men and 3 women be chosen to form chosen from a group of 7 men and 6 women? Okay, so in part 1, okay, so we have a committee of 3 men and 3 women. 1 2 3, 1 2 3, right? So this must be the man. Okay, so this must be all the 3 men, this must be all the 3 women, right? So over here, how do we choose them, right? Would be the first set. How many men do we have? So we have 7 of them. We're going to choose 3 of them, right? So it's literally 7C3. Okay, then the second group over here would be women, right? So this would be 6C3. So in total, it will be just 700, just like that. Okay, so this will be just part 1. Very simple, straightforward. Now, then for the second part, the oldest of the 7 men is A, the oldest of the 6 women is B. It is decided that the committee can include at most one of A and B. So in how many ways can the committee now be chosen? So let's look at method 1, the way, how do we think about this? Okay, so method 1, right, we need to include at most one of A and B, right? So we have to split by cases. So case 1 would be no A and no B. Okay, then case 2 would be the case with A and then no B. And then case number 3, right, would be no A, but we have our B over there. Okay, so then we have to calculate based on how many cases are there lah. Okay, add 1 by 1. So this is method 1. Okay, but as you can see, right, method 1 make use of like many cases, right? So let's think of another way. Is there an easier way to do this? Okay, so let's take a look at method 2. Okay, sorry, I think let's elaborate a little bit on method 1. Okay, so method 1, no A and no B, right? So out of 7 men, so we have 6 men left, choose 3. Then we have 6 women, right? So 5 left, choose 3. Okay, plus the second case, we have A, the one with A, so it will be A is there, but out of the 6 remaining men, we choose 2. And then out of the 5 remaining lady, because we're not choosing B as well, we are going to choose 3. Okay, then for the last one over here is no A, so A will not be inside, so 6 remaining men, we choose 3. And then B is already inside, so the 5 remaining women, we choose 2. Okay, so it's a matter of playing with this 6 and 5 and playing with choosing 2 or 3 of them to form the committee, because one already taken the seat, so we left with 2 more to choose. Okay, something like that. Okay, so this one over here, if you add, it should be giving you 550, if I'm not wrong. Okay, so let's take a look at method 2. Okay, method 2, what would be the remaining case? Let's look at the remaining complement case. So actually, this is actually case 4, where you have A and B inside, right? Just one case, as in like this is A and B inside, just one case, right? So because of that, right, what we can do is we can take the total number of cases minus of this case. Okay, so for this one over here, right, how many ways do we get this? So this would be the number of ways with A and B. Okay, number of ways with A and B would be, now A is already inside, right? So we have 6 remaining people, and we have 2 remaining seats. So 6 choose 2. multiplied by B is already inside, so we have 5 women left, and we're choosing 2 seats also. And then this one will give us a number 150. So what can we do would be number of ways without A and B would be to take the total number of ways, which is 700 minus 150, so it should be giving you 550 as well. So the method 2 is what we call the complement method, okay, which is to look for the complementary case, the one that completes the whole situation, and we just take the total minus of that last final case. Okay, so this would be how we analyze question 8. And as you can see, method 1, method 2 both are okay. It's just that method 2 more often than not is easy, and I think we usually can spot this method 2 by observing these kind of phrases over here. Okay, at most one of A and B. Okay, let's look at question 9. So over here we have a team of 6 people to be chosen from a list of 10 candidates. Find in how many ways this can be done if the order of the people in the team does not matter. Okay, order of the people in the team does not matter. So this is just simply 10 choose 6, right? And this is going to be 210. Okay, part B. And then if the team consists of 6 people in a definite order, so over here the order matters more. So instead of 10C6, we will have 10P6 because of the arrangement. So this one will be 151 and then times 151,200 ways. Okay. Then part C. Now if the team consists of a first pair, a second pair, or a third pair, okay, but the order within each pair does not matter. Okay, so we are going to look for 3 pairs over here. So let's take a look over here. Now we have 6 over here. Okay, and let's look at 3 pairs. Okay, the first pair, the second pair, the third pair. Okay, so now let's look for the number of ways to calculate the first pair. Okay, so this one over here, it will be done together within the same case, right? So now currently we have 10 people. We are going to choose the first pair. Choose 2 people first. Then, okay, the second pair comes from the remaining 8 people. Then choose another 2. The third pair will come from the remaining 6 people. Choose another 2. Okay, so with this, we will get 18900. Okay, the order within the pair does not matter, so we don't have to play with the permutation. We just need to look for the combination will do. Okay, so mainly this would be the way we think about part C. Okay, so hopefully the phrasing in the question may seem a bit confusing, but hopefully you can just draw the image down and just try to understand it literally. Okay, you don't have to think too far, just literally. First pair, choose second pair, choose third pair. Okay, so mainly like that. Question 10. In how many ways can 5 copies of a book be distributed among 10 people if no one gets more than 1 copy? Okay, so over here, right, would be 10 people. I will just choose random 5 to give. Something like that. So this would be just 10C5. 10C5, right, you press your calculator, should be 252. Okay, just like that. So part 1 is quite easy. Okay. And also, once again, if you find that how do I get the 10C5, right? You just write down what I say, okay? So it will be like 10 people, choose 5 to give. Okay, something like that. So that it will help to explain, right, the working that we write. Okay, so especially in your exam also, if possible, just try to explain if you have time. Okay, now in part B, in how many ways can the 5 different books be distributed among 10 people if each person can get any number of books? Okay. Okay, alright. So over here now we're going to distribute 5 books. Okay. So over here I have 5 books to give away. 5 books. So all these are books. Okay. So for the first book, how many people I can give away to? I can give away to 10 people. Right? Second book, how many people can I give away to? I can give away to also 10 people because I can give it to anyone, because if they can get repeated copies, right, I can just give it to anyone. Now, then the third book, I can also give to 10 people. fourth book I can give to 10 people, the fifth book I can also give to 10 people. So the number of ways would just be 10 to the power of 5. So this would give us to 100,000 ways, like that. Okay? So this works when we can do repetition, or this works when like each person can get any number of books. It's like there's a repetition going on. Okay, so or like you can, like the same collection can be considered case within this case and next case and the different situations, something like that. Okay, so we will be using this way of counting the multiplication principle to count, okay, for this kind of case. So I think let's compare this with the first one again. Okay, so the first one, right, same thing. This will be the first book, second book, third book, fourth book, and fifth book. Okay, so if you want to compare, right, it will be the first one I can give it to 10 people. If I don't want the same person to get it, I can only give it to 9 people. Then I can give it to 8, I can give it to 7 and 6 people respectively, right? 6 choices to give, right? So at the end of the day, right, this multiplication, right, is exactly 10C5 over here. Okay, so another way of doing part A is also to consider the multiplication principle. Okay. Okay, so that's all for our short video, and question 11 we've already covered in class, so I hope you've got that down well lah. Okay, so that's all for this short video, and thank you so much for your kind attention. Okay, so all the best for your exams, and I'll see you in the next video. Okay, bye bye.